Yes, Saurav, I'm audible.
Yes, sir. Good evening.
Good evening. Today, which topic you have
Sir, you
prepared?
can ask me from organic spectroscopy.
Organic spectrum.
Yes.
Yes, first of all, basic introduce yourself, then we will discuss.
Okay. Good evening, sir. My name is Saurabh Shamdar. I'm from Kolkata, West Bengal. I have completed my class 10th from APC High School for Boys, Salt Lake, and my class 12th from Bidhannagar Government High School. And I have completed my graduation from Calcutta University in 2021, and I have completed my master's in chemistry from IIT Bombay in 2023. And I have qualified national level exams like CSI, NET, GATE, IIT-JAM, and cracked interview uh, and qualified for a interview for BRC. And I was offered integrated PhD uh, positions in either Pune and Bhopal. And apart from studies, in my free time, I like to play badminton, and and I also do physical exercise, which keeps me energetic throughout the day. So that's a brief info about me. Thank you.
Yes, good. Your hobbies is, first of all, your name is Saurabh. What the meaning of your name? Explain.
Yes. So the meaning of my name, it means that the smell of a flower, like the smell of a flower, is very soothing to a human being. So that the meaning of Saurav is that, like the good smell a flower carries.
Yes, good. Nowadays, you working in NDPC assistant chemistry, yes, no?
Yes, currently I am working. I am under training. I have joined NTPC in October 2023.
Yes, what the role of NDPC in our country? What the main motto of NDPC?
So NTPC is a power power generating company. Like NTPC has several projects all over India uh, that generates power and electricity. The currently it has around more than 70,000 megawatt capacity of electricity it can generate. So it uses several techniques to generate electricity. The majority of the electricity is derived from fossil fuel like coal, and some portion of it comes from renewable sources like solar and hydro.
Yes, good. Yes, your post is assistant chemist in NTPC department. Yes, no, chemistry department. What
Yes,
the role of
assistant
assistant
chemist.
chemist in your department?
In general, if you look at NTPC, the role of a chemist or chemistry department is to supply purified water. Like in NTPC, what they do is the basic principle is that they burn coal and derive energy from it, heat energy, and they use that heat energy, and using that heat energy, they convert water into high quality steam. That steam is used to rotate the turbine at very high RPM, and then the mechanical energy from turbine is converted to electrical energy. So now through a generator. Now the role of chemistry there is to provide that water which is required in ultra pure form, because any slight amount of impurity present in that water will hamper the turbine reactivity, and it can damage or corrode the turbine blades. So that's why our role is to supply that water. We in several like in the plant where I'm posted, we take sea water, and we use that, we purify that water from the sea water has an inlet conductivity of 50,000 microsiemens per centimeter, and we using that water we convert it into DM water, or we can call it deionized water of less than zero point 0.1 conductivity. So from 50,000 conductivity, we are making it ultra purified to less than zero point 0.1 conductivity. So that is our role, one major role. Another role is to produce drinking water from that seawater. Drinking water and several varieties of service water can also be produced from that.
Yes, good. Your hobby is playing badminton.
Yes.
Yes. Can you explain? Describe your hobby. How to use your these in a day, week, in a month.
So I usually play it in my free time, like occasionally 2 or 3 times a week. So badminton is a sport I am used to play it since my childhood. So I have in my childhood I used to play it in the every winter. Like winter existed for 2 to 3 months. So we used to make this court on a you can say on a ground, and then we used to hang the badminton nets, then we used to play there. From there I developed the interest on playing badminton, and now since I'm employed here at NTPC, we have the facility of indoor badminton. So there I go in my free time with my friends and play there.
Yes, good. Your native place is Calcutta, West Bengal. Yes, how
Yes,
do
sir.
you feel about your district and West Bengal? Explain briefly.
Mm. Calcutta is a wonderful place to live. Like the food, the major good thing about Calcutta is the food. Like you get every quality of food from a variety of fish and fish, and there are several kinds of sweets. We have a very Bengalis have a very sweet tooth, so they always like to have sweet at the end of every meal. So the main thing about my place is the food and the people. So they are also very sweet, and they also like to eat sweet.
Yes, good. Yeah, next move on laboratory section. What is lab and what the elemental analysis?
Lab, my lab experience, as in,
Yes, yes,
so in my undergraduate, we used to have lab courses where we were accustomed with several titration techniques, like normal acid base titration to potentiometric to pH metric and complexometric titration. Then also we did elemental analysis, like functional group, organic functional group analysis through Lassen test and functional group identification. And we also did inorganic qualitative estimation of several acidic and basic radicals. And in my MSc, we have advanced lab courses. Like we did several computational tools like Gaussian software we learned at IIT Bombay, Gaussian software and different other how to use ChemDraw and different spectroscopy techniques like NMR spectroscopy, IR spectroscopy, CD spectroscopy. So these are the different techniques we learned during my MSc.
yes, good. Yeah, next go through on laboratory sections. How to determine elemental analysis? What is elemental analysis?
So elemental analysis is like in elemental analysis, we determine the functional group present in a molecule by first mm, doing the fusion test, we fuse it with sodium metal, and from that we can obtain the kind of functional group present, like whether it contains sulfur or chlorine, or nitrogenous compound. Once we confirm that, then we go to the corresponding functional group identification. Like for nitrogen, we can do amine test. For sulfur, we can do the presence of sulfur and halogen test. So that's how we determine the kind of functional group present in that.
Yes, functional group. Carbohydrate, aldehyde, ketone. How to detect in a lab? Which experiment?
Hmm. Carbohydrate, aldehyde, and ketone. So aldehyde and ketone can be distinguished by Tollens test. So from Tollens test, aldehyde they will give positive test, and the ketone they will not give positive test.
Yes, good basic idea. Next, move on your MSc project is name is green hydrogen production and using sensitization.
Yes.
Yes. What the main application of this project and uses?
The, yes, the main application is like green hydrogen production. Currently, we can see in our country or in the world that we are day by day growing to be power hungry. So we need power for everything. To recharge, to charge our mobiles, to use electricity like electric bulb, AC, fan, etc. So the demand of power is growing day by day. So the major source of energy is currently derived by exploiting fossil fuel, which is harmful for environment. Like if we use fossil fuel to derive electricity from it, we are producing carbon dioxide at the same time, which is harming our environment. So there comes green hydrogen or hydrogen as an alternate source. So hydrogen produces a huge amount of energy in the form of H chemical bond, and hydrogen can be produced in a green way by not involving any fossil fuel, and that hydrogen can be stored and can be further used in a you can say fuel cell, where we can derive energy from that. So green hydrogen is an alternate to conventional source of energy like fossil fuel kind of energy. So green hydrogen it is the future where the current research is modern research is going on to develop various new kinds of catalyst, where the hydrogen can be produced in a much more efficient way, and it can be stored in a large excess capacity, and we can exploit it to derive energy from it.
Yes. Next, your project is CO2 reduction. What the main application of this one?
So as I have already said that increasing concentration of CO2 in the atmosphere is harming our environment. So our goal should be to minimize the CO2, minimize the concentration of CO2 in our environment. So there are several ways to minimize it. So one of the most popular technique to minimize the CO2 is known as CCUS. So what is CCUS? CCUS is carbon capture, utilization and storage. So what we can do, we can minimize the amount of CO2 by capturing it, or by utilizing it, and by storing it. So capture is a process where we capture the CO2 present and derive it back to the earth. And utilization is we convert CO2 to several kind of molecules, the useful chemicals. Like from a waste CO2, we can produce useful compounds like methanol or formaldehyde or formic acid. So these are industrially useful compounds. So that was our goal, to convert environmentally harmful CO2 to useful chemical compounds via the process of carbon utilization.
Yes, good. Suppose as a scientist, how to control in CO2 emission in India? Which type of procedure and method from your side?
So currently several projects are going on, where they have shown that they can convert CO2 to methanol by using different kind of catalyst or electrocatalysts. So that's how we can reduce the concentration of CO2. Okay, and we can also do carbon capture, and we can store it, and that's how we can. These are the several ways we can minimize the amount of CO2.
Yes,
And we
good.
can another way we can do that. Another major, we have to understand major goal why CO2 is increasing use of fossil fuel. So if we move from a fossil fuel based energy to a green renewable energy source like solar, hydro, okay, or hydrogen product or hydrogen based energy, then we can minimize the fossil fuel burning. So that will also reduce the amount of concentration of CO2 in the environment.
Yes, good. Next point regarding to BRC, Bhava Atomic Research Center. What the main motto of BRC in our country? What the main
Yes,
purpose?
Bhava Atomic Research Center. uh, the main agenda of Bhava Atomic Research Center is to find a alternate source of energy production by exploiting nuclear nuclear radioactive molecule. So they use radioactive molecule, and they do a controlled radioactive decay reaction. So that way it is not environmentally harmful also, and we can generate electricity or other useful energy from it. So that is the main role of Bhabha Atomic Research Center.
Yes, good. Next question, why will you become a technical officer in BRC? What the role of technical officer in BRC? Explain.
So in general, as a scientist at BARC, uh, will help me to understand this uh, need of alternate source of energy in a better way, and where I'll be able to I'll be able to get involved in the R&D R&D section, where different new methodologies will be tested, and I'll be able to be a part of it and lead the research to make our country a non-fossil fuel based energy economy.
Yes, what the major next question is, what is scientist? What the main major responsibility of scientists in our country?
So major responsibility of a scientist is to do several R&D activity work, like in 2020 when COVID-19 break out. So everybody was frightened. What will happen next? How are we going to survive? We don't have any medicine for it. We have no what do you say? We have no cure of it. So that time we understood the need of a scientist in a modern world. So they were the people who discovered the structure of the COVID virus in a very in very quick way, and also the using that they also developed vaccines from it. So that is the major role of it. When some emergency comes, they are the first one to scientifically deal with it, and they help the economy and the society to grow in a positive way. So that is the major role of a scientist.
Yes, good. Next, move on. Today topic is organic spectroscopy. Yes.
Yes.
First of all, question is what is spectroscopy? What the main application of spectroscopy in chemistry?
So spectroscopy, it is actually defined as the interaction of electromagnetic radiation with matter. And in chemistry, we use the principles of spectroscopy, or we employ spectroscopy to deduce a structure of a molecule, like what kind of functional group is present in that molecule, what is the chemical structure, how does it look like actually. From several spectroscopic data we can deduce that.
Yes, good. How many types of spectroscopy?
There are several kinds of spectroscopy, like UV visible spectroscopy, IR infrared spectroscopy, NMR spectroscopy, mass spectroscopy, etc.
Yes. What the difference between organic, inorganic, and physical spectroscopy? These the example of each one.
So in physical spectroscopy, we study mainly the theories of a spectroscopy, of a particular kind of spectroscopy. Like it tells us about the selection rule of whether a transition is going to be allowed or not. And what kind of model a particular spectroscopy follows. In physical spectroscopy, we study mainly rotation, vibration, Raman, and electronic spectroscopy. Whereas in inorganic spectroscopy, we use several spectroscopic methods to identify the structure of an inorganic molecule, like complex, metal complex, and main group inorganic compounds. So they are the spectroscopies we mostly use are NMR, hetero NMR spectroscopy, and uh, EPR spectroscopy, and Mosbar spectroscopy. And in organic spectroscopy, we study different spectroscopies are UV visible spectroscopy, IR spectroscopy, and NMR and mass spectroscopy, that helps us to deduce the structure of an organic compound.
Yes. Organic UV, IR, NMR, organic. Yes, no.
Yes,
Inorganic.
EPR, Mosbar,
Yes.
hetero NMR.
Mass. And physical, rotational, vibration, electronic, and Raman. Yes. First of all, your topic is organic spectrum.
Yes.
So first of all, first topic is UV visible spectroscopy. What is UV visible spectroscopy and what the main application of UV visible spectroscopy?
Okay, so UV visible spectroscopy, here the source of electromagnetic radiation is UV visible light. So the wavelength corresponding to this UV visible region lies from 200 nanometer to 800 nanometer. So here we pass UV visible light to a kind of organic sample that absorbs that light and undergoes excitation to a excited state, and then relaxes back. So the UV visible spectroscopy helps us to identify uh, the conjugation present in an organic molecule. If it is more conjugated, the UV visible absorption will correspond to a higher wavelength. And if it is not conjugated, it will be a lambda, the absorption maxima value will be at lesser value, at lying around 200 to 250 nanometer.
Yes. What is Beer-Lambert law in UV? What the main application of Beer-Lambert law in UV visible spectrum?
Yes, the Beer-Lambert law tells us that the change in intensity of a incident light and the transmitted light is directly proportional to the concentration of the sample and the path length of the sample. So that law helps us to mathematically quantify the UV visible spectroscopy phenomena by we can deduce absorbance and transmittance. So that helps us to quantify the amount of light absorbed and the correlation between the light absorbed and the concentration of the sample.
What the limitation of Weir's law?
Limitation is that Beer-Lambert law is applicable for particularly diluted sample. The concentration of the sample is very high, so then the plot of absorbance versus concentration, it deviates from the linearity when the concentration is very of sample very high. So its sample should be sufficiently diluted to follow the Beer-Lambert's law.
Yes. What the formula of Beer-Lambert law?
The formula like absorbance will be equal to log base 10 uh, I 0 by I, where I0 is the incident light intensity and I is the reflected transmitted light intensity, and it is equal to epsilon Cl, where epsilon is molar absorptivity, C is the concentration, and L is the path length of the sample.
Yes. Next, move on electronic transition. What is electronic transition? What the main application of electronic transition in UV visible spectroscopy, and how many types of electronic transitions? Can you explain one by one?
Mm, yes, there are different kinds of electronic transition. Like in UV visible, we have sigma to sigma star transition. We have pi to pi star transition. We have n to sigma star transition and n to pi star transition.
Which transition is so forbidden and allowed, and why?
So transition follows a selection rule, uh, which is derived from physical spectroscopy or quantum chemistry. So for UV visible spectroscopy, uh, it follows Laporte selection rule and spin selection rule. Like Gerarde to ungerarde similar transition will be allowed, but Gerarde to Gerarde and ungerarde to ungerarde will not be allowed. And for spin selection rule, the spin multiplicity will have to be same in the ground state and the excited state.
Yes, what the difference between a chromophore and oxychromes in UV, and what the main application of these one? Any example?
Chromophore is chromophore is the functional moiety present in a molecule which which is responsible for the UV visible absorption. Like if we have benzene, then the benzene unit, it can be called a chromophore. It induces the pi to pi star electronic transition, the pi electrons present in the benzene molecule. And oxochrome is such a functional group which itself does not show any visible activity. But when it is attached to a chromophore, it either enhances or decreases the light absorption capability. Like if we attach a NH2 functional group to a benzene molecule, its light enhancing capability is increased. So then NH2 is called an oxochrome.
Yes. Next one is what the difference between red shift, blue shift, hypochromic shift, and hypo
Red shift,
shift.
hmm. Red shift is known as red shift is actually increased wavelength of absorption. So if in a particular reaction, the after the product absorbs at a greater lambda max, it says it has undergone red shift. Similarly, blue shift will be shorter in absorption maxima, shorter in wavelength decreases. And there is two different hyper and hypsochromic shift. Hyperchromic shift is it is increase in absorptivity. Molar absorptivity increases in hyperchromic shift, and in hypsochromic shift it decreases.
What the main purpose of these one in UV?
Main purpose, like if we have a particular kind of reaction where we have phenol, it is treated with an alkali to produce phenoxide ion. So what will happen in that case? We are removing the proton from OH group, and oxygen is gaining excess electron. So the conjugation becomes more efficient in the product due to the negative charge circulation. So in that case, there will occur red shift in the absorption. So that can tell us about the confirmation of the reaction, that the reaction has occurred or not.
Yes, determine the value of lambda max. Yes, no.
Yes.
What is Woodward-Fisher rule? What the main application of Woodward-Fisher rule?
Woodward-Fisher rule helps us to calculate lambda max uh, for cyclic type of molecule, like if it is a homoannular diene or a heteroannular diene. They have given a particular values for such kind of systems. Using those values, we can deduce the absorption maxima for organic molecules.
What the difference between homo and heteroannular? How to determine what the value of this one?
Homoannular diene is that we call it cis diene. So with respect to the single bond, the two adjacent double bonds are cis to each other. But in heteroannular diene, the two double bonds are trans to each other with respect to the single bond. And homoannular diene absorbs at a higher wavelength, around 253 nanometer, whereas heteroannular diene absorbs at lower wavelength, 215 nanometer.
Yes, good. Next one question is what is absorption band? Now, how many types of absorption band in UV? What the uses?
Absorption band, it corresponds to the absorption profile of a particular type of molecule. Like in UV visible spectroscopy, here electronic transition occurs. So electronic levels of a molecule has that corresponding energy gap is very high. So in between electronic levels, we have several vibrational levels and as well as rotational levels. So when we are supplying sufficient energy to the molecule to correspond a electronic transition, so there will be associated rotational and vibrational energy level changes. So that's why we get a band type of structure, a band type of spectrum in UV visible that corresponds to a particular electronic transition associated with several other vibrational and rotational transitions from ground state to excited state.
Yes, good. What is the source of UV visible spectroscopy?
So we can use tungsten filament, tungsten filament and sodium or deuterium lamp as a source of UV visible light.
Yes, UV hydrogen deuterium discharge lamp. Yes.
Hmm. Hmm.
Visible tungsten
Yes.
filament.
Yes.
Any limitation of UV visible spectroscopy?
Limitation can be it is only useful to deduce whether a molecule is conjugated or not, but it does not give us any extra information like what kind of functional group present in there. So UV visible is limited in that sense.
Yes, UV visible is can't be used to measure solid or gaseous sample. Yes, no.
Hmm. We cannot use it for solid gaseous.
Yes, good. Your next topic is IR spectroscopy. What is IR? Infrared spectroscopy. What the main application of infrared spectroscopy?
IR spectroscopy, it is known as infrared, and the corresponding wavelength lies from 400 to 4000 centimeter inverse. Yes, and the main application of IR in organic molecules are it can help us to deduce the kinds of functional group present in a molecule. Like different functional group will correspond to different wave number.
Yes. Main application is functional group determination and identification of two compounds, same or different.
Yes, yes. Hmm.
But the source of IR and for IR.
Source of IR, I don't remember right now. I have
Yeah,
to check.
near IR source is Nast filament. For
Near air
IR,
sources.
Nast filament. Nast filament.
Okay.
Next, for IR is Glover. Mercury arc.
Okay.
What is molecular vibrations in IR? How many types of molecular vibration in IR? What the uses of these one in IR spectroscopy?
Molecular vibration. There can be two kinds of stretching vibration. One is known as symmetric, and one is known as antisymmetric stretching. There are different kind of bending vibration, which can be in plane and out of plane. Like one is scissoring, another one is rocking, and there is wagging. These are different kind of vibrations.
Yes. What is coupled vibration?
Coupled vibration is that if we have a bond BAB, so there are two bonds associated to A, two bonds. So what can happen that these two bond can vibrate at the same time to produce two different stretching. One is symmetric and one is antisymmetric. So this is called coupled vibration.